So in chapter 7, we are going to speak a lot about polygons. And in those polygons, there's going to be a lot of stuff happening. We're going to start out today just trying to find a pattern, trying to find out how you can figure out how many degrees are inside of a polygon. Because the thing is, I can tell you right now there's 180 degrees inside of a triangle. I can tell you right now there's 360 degrees inside a quadrilateral. I can tell you that there's 720 degrees inside of a pentagon. But the thing is, it's really tough to keep memorizing those numbers. So the way that we're going to work through it is we're going to figure out the formula that will produce how many degrees are inside each of these figures. So what I'm going to start with is we're going to start just by naming these things. So the first one is obviously called a triangle. The second one is called a quadrilateral. Quadrilateral just means a shape that has 4 sides. So this is a shape that has 4 sides. Now, a lot of you think that 4-sided shapes are all called rectangles, or all called squares, or all called something like that. There are a billion different 4-sided shapes. We're going to handle quite a few of them. So I just want you to kind of understand as we work our way through, there are a lot of different 4-sided shapes. A lot of them have a lot of different qualities. So just make sure that you call all 4-sided shapes for now quadrilaterals. Okay. 5-sided is a pentagon. This is 1, 2, 3, 4, 5, 6. So this is a hexagon. And then this is 1, 2, 3, 4, 5, 6, 7, which is a heptagon. 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 All right. I'm not going to ask you to memorize those things, but it's kind of important to know that.
What's an n-gon?
N-gon just means any figure with any number of sides. It's a general way to say any shape out there. Because what we're going to do is we're going to find a rule that applies to every single shape known to man. Okay? We're going to find a rule that allows us to find the number of degrees in any shape. So what we're going to do is we're going to really, really pay attention to the pattern that we see. Now, the pattern that we see is we're going to kind of figure out and try to relate the number of sides to the number of triangles inside the shape. All right? So obviously there are 3 sides in a triangle, 4 in a quadrilateral, 5 in a pentagon, 6 in a hexagon, and 7 in a heptagon. Right? So now what we're going to do is we need to figure out the number of triangles inside the shape. Now obviously a triangle has 1 triangle inside of the shape. You can't draw any more triangles inside the shape unless you literally draw a triangle inside the shape, which isn't what we're going to do. So there's 1 triangle in there, and we know that there's 180 degrees inside the triangle, right? So we're going to try to find the number of degrees in each of these shapes. The next thing that we're going to do with the quadrilateral, and when I say break out to see how many triangles there are, we are going to do this. So how many triangles are there inside of a quadrilateral? There's 2, right? And if each triangle is worth 180 degrees, right? Because every triangle is 180 degrees. So that's 180 plus 180, which gives me 360. So then the next one, again, a lot of people, when they try to draw triangles, they try to draw them really weird by doing things like this and making a whole lot of crossings and stuff. And they say, well, there's 1, 2, 3, 4, and they count all of those. What you need to do is you just need to make sure that you fill out the entire shape of triangle. So if I go like this, notice how I've filled up that entire shape of triangles. That entire shape is now a triangle. So the least number of triangles that you can draw in a shape. So how many triangles are there in a pentagon? 3. Now there's 180 degrees inside each of those, right? So 180 plus 180 plus 180 is 540. So there's 540 degrees inside of the pentagon.
Let me guess, which one's 4?
Okay. So now if we look, we can go here, we can do another one here, we can do another one here. Now there's a lot of different ways that we can draw the triangles, but obviously we can see that we have filled this shape up the least number of triangles possible, and there are 4, which means that there's 720. Right. And the last one we have to have, any guesses how many triangles? 5.
Can we do 1 n-gon?
So there's 5, which means that this is going to end up being plus 180, which is what? I can't do
900. Okay, so we do 1 n-gon.
We're going to talk about it in a second. Okay. All right. So now what I need you to do is I need you to see if you can find a relationship between the number of sides the number of triangles, and what happens with the number 180. So what's the relationship that you guys can see between the number of sides and the number of triangles for each of these?
There's always,
They do all go by one.
but they're all, there's two triangles for every, there's two less triangles on their side.
So every time Josiah is noticing that there's two less triangles every single time, right? There's two less triangles every single time. So what we do is we call the number of sides n. N is the number of sides. So every single time we're talking about the number of sides. So a quadrilateral has 4, a pentagon has 5, a hexagon has 6, so on and so forth. An n-gon has n number of sides. It's just saying we don't know how big the shape is yet. We're given it, it's a general shape. It's a shape that exists out there. Okay. So it's a shape that has a certain number of sides, but every time, notice, the number of triangles inside the shape is always 2 less than the number of sides, right? So I could figure out how many triangles there are by taking the number of sides and subtract from 2. Every single time I just take the number of sides, I take 2 away, and that gives me the number of triangles. Now, how did I get this number right here?
By adding up all the triangles.
I kept adding 180, and what is repeated addition called? You know? It's called multiplication, right? So instead of adding 183 times, would it be possible for me to multiply 3 times 180? Instead of taking 4 and 180 going 180 plus 180 plus 180 plus 180, could I do 180 times 4 and get 720? 180 times 5 and get 900. So if I want to figure out how many degrees there are in any shape, I'm just going to take n minus 2, which is the number of triangles, right? And I'm going to multiply that by 180. So your formula for figuring out how many degrees there are in any shape is going to be n minus 2, where n is the number of sides, times 180. Now that's a really, really easy concept if you remember what n is, and if you know when to use this. If you don't know when to use this, this gets much more challenging. Okay? So n minus 2 times 180 is going to be what your interior angles are going to end up being. Any questions that you guys can think of, any issues that you guys can think of, or anything else? All right, so let's go through the formula. Make sure that we have it written down. Everyone knows exactly what's going on. All right, so the polygon interior angles theorem. So this is what we just talked about, the degrees inside of a triangle. So the degrees inside of a triangle, the sum of the interior angles of a convex polygon is n minus 2 times 180.
And then you said n is like the number of.
N is the number of sides. N is the number of sides in the shape. So like a stop sign is 8 sides. It's an octagon. So if I wanted to figure out the number of sides or angles in a octagon, you would take n minus 2, so 8 minus 2 times 180. So let's go through that example and just draw this picture and see the next example. So a stop sign has 8 sides. So my formula would be 8 minus 2 times 180. So 6 times 180. 6 times 180 is what, 1140? 1180? No, 1080. Mental math is failing me. So there are 1080 degrees inside of an octagon. Now this is going to turn out to be a big deal later. Okay. Now right now it's not that big of a deal because it seems like it's a pretty just rinse and repeat kind of thing. Right? You count the number of sides, you subtract 2, you multiply by 180, you move on, everything's great. It's going to get more challenging because what I'm going to do in the future is I'm going to do things like this, and I'm going to draw a shape on the inside, and I'm going to say, okay, now tell me about that shape. Now, if you can figure out how many degrees there are inside the whole shape, now we can start to break it down and figure out how many degrees are in the smaller shape, so on and so forth. Okay, those are things that you're going to have to be able to do. So right now, take a lot of be excited in the fact that these problems are literally just going to ask you, keep finding this angle, keep finding this angle, keep finding this angle. And it's going to be pretty straightforward because it's going to get more challenging in the future. Just make sure you're ready to move on, which means you understand this basic concept first. Okay. the exterior angles theorem, this one's a little bit different. The sum of the exterior angles of a convex polygon. This one is different because it's a lot easier. Is 360 degrees. So there is no formula for this one. If you see the word exterior angles, the answer is 360. Okay. See exterior angles is 360. Now this picture looks different. Okay. This picture looks pretty different because if I take any shape, an exterior angle or the sum of the exterior angles is when they add on these little tails outside of the shape. So if you look, you can probably see those on your worksheet where they add on the little tails outside there. These things right here are the exterior angles. So it's saying that all of these things that have arrows drawn to them will all add up to be 360 degrees. Okay, so anytime you see something that has little tails, so like look through your worksheet and see if you can find any spot that has a little tail. The very
top
bottom
right. Top right.
So the very bottom right on the front.
Yep.
That one, you know that that thing is going to equal 360. I mean, you still have to do some work, but you just know that the angles are going to be 360. If you look at the back, everything in the second row, like the middle, that also, everything is going to equal 360. So it's just like in a triangle. You remember in a triangle when we kept doing things and we would do like angle plus angle plus angle equals 180 and then it would try to solve for x. Now we're going to do angle plus angle plus angle plus angle plus angle plus angle equals whatever we figure out for the number of degrees, and then we solve for x. So let's walk through a couple of these so we can see what they look like. This I'm going to leave for you guys because you can do this. The only thing I want you to know is that a decagon has 10 sides. So decagon has 10 sides. So I want you guys to try this right now, okay? So let's try this right now. Decagon has 10 sides, octagon has 8, 30gon, that's what n-gon looks like, has 30 sides, quadrilateral has 4, and 58gon has 58. Figure out the number of degrees on the inside of the triangle, or on the figure, and figure out the number of degrees on the outside of the figure. So every one of these should be a relatively quick calculation if you've got your calculator. So all we need to do is figure out the number of sides, and then we plug it into our formula. That gives us the easy part, right? Or I'm sorry, the hard part. The easy part is the exterior angle. Every one of the exterior angles will have the exact same answer. It doesn't matter how many sides there are. So every single time, the sum of the exterior angles is just going to be 360. So I can do all of that before having to do any work at all because this is the easy. I don't care what happens with any of these other shapes at all. I know that the number of degrees in an exterior angle is going to be 360. So now a decagon. How many sides does a decagon have? 10. So I'm just going to do 10 minus 2 times 180. So this is really just saying 8 times 180. And if I look at 8 times 180, does anyone know if that is off the top of their head?
360? No, 144.
1440. So there's 1,440 degrees. Now we already did an octagon. Octagon was 1080, right? 30gon is a little bit more. 30 minus 2 is 28 times 180. So how many degrees are there inside?
5,440.
Say it again. 5,000. 50, 40. Looks like a 56, but it's not. It's 5040. All right, quadrilateral we already talked about has 360. And then a 58gon would just end up being 56 times 180, which is what? 10,080. 10,080.
Yep.
10,080. So this is just how we figure out how many degrees there are in a shape. Once we know how many degrees there are in a shape, this becomes very straightforward to solve these problems. Because if you look at the next couple of problems, this is where we get into our calculations. So I'm going to do one of each of these, and then I'm going to let you guys work on this for the rest of the time today. Don't worry about the big table on the back. The big table on the back we'll talk about tomorrow. But right here, basically what I want to do is I want to add all of these angles together because my job is to find x. So what I want to do is I want to add all of the angles together. So it's going to be 123 plus 113 plus 145 plus 87 plus 2x plus x equals. I'm going to give you a second to write that down and then think about it.
So everything in that triangle has to equal 360.
Not 360.
What's it trying to equal?
I don't know. What is it trying to equal?
Trying to equal all sides out here.
It's trying to equal to however many degrees there are inside that shape. So how do I figure out how many degrees are in that shape?
By adding both sides.
No.
By creating triangle.
Nope. What did we just do? We did that. Side minus 2 times 180. N minus 2 times 180 will tell me how many degrees are inside that shape.
Oh.
So it will tell me what all of the angles add up to. So what I want to do is figure out how many sides there are. There's 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 times 180 will be 4 times 180, which is 720. So I now know that this stuff will all add up to give me 720. So it's really just like all the triangle problems. There's just one extra little step that you have to make in between the setting it or adding them all up and setting them equal. You got to figure out what they actually equal. And what they actually equal is just adding all of the, or doing N minus 2 times 180, figuring it out. Yeah.
So to find our 2x and x, do we add like all the numbers up together that we have?
Absolutely. So when we solve this, what we should do is we should combine all of our like terms. So you'll notice all of those terms right there don't have an x. All of these terms right here do have an x. So combine all the terms that don't have an x together, combine all the terms that do have an x together, and then we're going to be left with this. Yeah. So I'm going to add all of these things together. I'm going to do 123 plus 113 plus 145 plus 87. Has anyone done that already? 400 what? So 468 plus 2x plus x is going to give me 3x equals 720. Now, is this an equation that I should expect everyone in here should be able to solve?
Right now, yeah.
Sure. Because it's just subtracting 468 from both sides, right? So we minus 468. And then it's going to give me 3x equals what's 720 minus 468? What'd you say?
84.
No. 396?
I miscounted.
Oh. 252.
84 would be x, correct?
Probably. So 3x equals 252. 720 minus 468 is 252. So divide by 3, divide by 3, and I get x equals 84. So this is specifically asking me to solve the value of x, and that is how we solve the value of x. Every one of these problems is done the exact same way. It's just going to equal something else at the end of the equal sign. Everything else is done the same way. Add them all up, combine your like terms, set it equal to how many degrees are inside the figure. Okay. These ones are a touch more challenging than ones like these. The what one? Yeah, after we do this. So this one,
That one equals 360.
this one's a little bit easier because I don't have to do n minus 2 times 180. So this one's really nice to me because it tells me that it's exterior angles, and if it's exterior, it adds up to 360. So I don't have to do the n minus 2 times 180. There's no extra little step. So all we have to do is add together all of our angles. So 93 plus 46 plus 3x plus 62 plus 4x plus 47 equals 360. One thing that I always do before I end these problems at all, I make sure I have all my angles, because it's very possible that you just skip an angle, you miss an angle, you don't have the right number. So I know I'm starting with 93, so there's 1, 2, 3, 4, 5, 6 angles. Make sure I have 6 angles. 1, 2, 3, 4, 5, 6 angles. So I've got them all. Now I go through, and I always make the extra step of underlining the little like terms. So I know I have a 3x and a 4x, and I know that I have 47, 62, 46, and 93, underlining my like terms so I know that I'm not going to miss them. Okay? So what do you get when you have 93 plus 46 plus 62 plus 47?
248. 248,
I'll take the hard part. 3x plus 4x is 7x.
that's 360.
It was. So equals 360.
What then,
And
you
now-
subtract all. Yeah.
Go ahead,
So
go ahead.
these 112,
So minus 248 gives me 7x equals 112
would then equal 16.
divided by 7 divided by 7, and that gives me x equals 50. So that's how every single one of these problems works. Every single one. Add up the angles and you equal it to either 360 or n minus 2 times 180.
And you can plug back in the number what we get for x inside of the equation, it should be the same.
It's pretty easy.
When you plug it back into the equation, you would then just add all of the angles up and they should equal whatever it equals in the beginning. Okay, which one did you say you wanted to do? On the back, top middle? Yes. I'm gonna have you guys I'm gonna help you set this up, but I'm gonna make you do the math on it. Okay? I'm gonna help you set it up, and then the math is something we can talk about tomorrow if we need to, but I don't wanna take away too many math problems for you to kind of challenge your algebra. So first things first, I'm going to set this up by adding all my angles together. So I'm just gonna start out and I'm just gonna go from top all the way around. So 9x minus 14 plus 9x plus 1 plus 10x plus 5x plus 5x plus 10x plus 9x plus 1. Is that homework? This is gonna be homework, yep. Everything except for the table is homework. Okay, so I've just added everything up. Once I've added everything up, I need to set it equal to something. And what am I gonna set it equal to? N minus 2 times 180, right? So I'm gonna figure out how many sides there are. There's 1, 2, 3, 4, 5, 6, 7 sides. So 7 minus 2 times 180 is the same thing as 5 times 180, which is 900. Now it's the exact same problem as last time. Combine your like terms, solve the equation for x.
How do you do like combine?
Do same exact way that you did before. Combine your 9, your 9, your 10, your 5, your 5, your 10, your 9.
Oh, so you just do like.
1, and there's 1, negative 14. Combine your like terms.
So
Solve.
you're adding the x and then
Adding the x's and then adding and subtracting the constant. Okay, so I'm gonna leave these for you. You have 7 minutes. I want you to try to finish this as best as you can. Tomorrow, you will have a homework quiz, which is going to be paper pencil, not on your worksheet. So your worksheet isn't super important to have fully completed, but it's a good thing to have practice. But you're gonna have just a paper pencil, 2-question homework quiz. Okay.
If it is track.
Right? Yeah, you thought.
Wait, I think that